There's at least 24 no-code data science platforms that exist today, and they range from cheap to expensive. A real data science bachelor's degree would have less coding than a computer science degree. Computer science is not science, it is applied engineering. Do you have data governance? Is the data clean? How do you know it's clean? Do you have any metrics on that? Don't get influenced by marketing AI, even though no matter how powerful it is and how interesting it is. 95% of real-world machine learning models in production today is like going to a used car lot, taking that used car home, and then you're modifying it with new features.
Alrighty, so on episode 1 of Myth and Reality, we are going to be diving into a variety of different topics with your expertise, John. And the first thing I want to talk about is consciousness in AI. First of all, can you just break down what is consciousness when it comes to AI?
Sure. So consciousness in general is self-awareness with the integration of information. So in other words, the ability to recognize oneself as an entity, but subjectively. So humans and animals can only do this right now, not machines. Also, you have to have the ability to combine different inputs to be conscious. So for example, you need audio files for conversations. You need image and video files for reading someone's face as they talk to you, and so on. So unfortunately, we cannot identify where consciousness happens in the human brain, even though we experience consciousness, of course. So consciousness is it's also not binary. It's not a black or white thing. Either it happens or it doesn't happen. Hence the expression of being half awake or semi-conscious. So the best way to kind of deal with this is to provide an analogy. So 1,000 years ago, humans thought the world was flat and would say things like, look across the horizon. When you walk, obviously it's flat. Why are you denying my experience? Of course, we all know today that the earth is not flat, but it's round. But the same could be said about consciousness. We cannot, we can experience and identify consciousness without measuring it or knowing where it comes from. So most importantly, human beings also have no consensus about what exactly is consciousness, especially within the scientific community. Now, what does this have to do with the AI industry? Well, it's more marketing than science. Since science is not settled with consciousness, some people believe, not everybody, that they're taking advantage of selling their products and services by, since that the amount of regulation in AI products is little to none, and you can't, a company can't get sued. Some people feel free to say, yeah, our AI product is conscious. Look at it. It's amazing, isn't it? So, and you're unlikely to be sued. So there's a big financial incentive in terms of marketing to draw more customers by exaggerating your product's consciousness as a novelty, as an emotional appeal, and whatnot, to charge a higher price. If not charge a higher price, then maybe later. Or more importantly, to basically drive the stock price of your company higher, period, full stop, nothing else to discuss. So that's a major driver within consciousness. Also, another aspect I would say is that if the AI product produces any errors or biases, you can simply just say, hey, it's learning, like a little kid, and it'll allow you to avoid responsibility. So there's that one aspect about saying that it's conscious when in fact it's not really conscious. So as long as human beings input data into machines, they can only mimic humans. Machine consciousness, separate from human consciousness, can only exist through machines from start to finish with no humans, by machines collecting the data, by machines processing the data, by machines writing the code, and by machines implementing it. So there's no absolute requirement for a human being to be in the loop for machine consciousness. And one last thing that kind of finalizes everything, we don't have enough energy capacity for machine consciousness to process audio files, text files, video files, all sorts of data to store it somewhere, just like the human brain does. We are not even close. We're decades away. For machine consciousness to truly work, we would need AI agents to discover on their own, not what humans have already discovered.
And do you think that AI agents will ever be able to have a consciousness?
I do. I actually do. As long as they are absorbing data, they're inputting the data, they're ingesting the data by themselves, not human beings. What we have now is we have human beings putting things that they discovered within the data and ingesting it into a artificial intelligence agent, for example, and that's causing it to basically mimic a human being. But a machine one day will be able to do that. I think really energy is much more of a bigger problem. So in theory, we kind of understand how it actually could work. I think a good analogy with this was that human beings knew how birds flew like 100 years before modern airplanes. They figured out the math, but they couldn't figure out how to make aluminum flat and flexible, let alone what aluminum was, and to be able to actually, go into a plane itself. So what I'm trying to say here is that we've kind of understand the pencil and paper approach of what consciousness is. We just don't have the energy to do what we want to do, let alone store the data and actually implement machine consciousness.
Awesome. That makes a ton of sense. And when it comes to AI agents, that's something that is a hot term right now. How would you break down what an AI agent is, and how is it applicable to a B2B business?
AI agents is a new label. One thing I kind of mentioned to a lot of people in my consulting and my coaching services is that we have a lot of label changing. So what that means is that when you do some internet searches on certain labels about artificial intelligence, such as AI agents, um, you'd want to know the old name. And you'll find out you'll come up with the same content or even the same web page, etc. AI agents or agentic AI is essentially reinforcement learning. That's the subcategory. We already have AI agentic products. They're robo advisors in financial services companies. They're autonomous vehicles. This includes not just cars, but also drones. So that's a different label. So when you open up the hood and look at the coding and the mechanics, it's actually the same thing.
Awesome. And I think that's a very interesting area to dive a little bit deeper. What would be an example of an AI agent versus something like ChatGPT?
Ah, well, there is a Venn diagram answer to that in the sense that um, some of the things that ChatGPT or other large language machines do has nothing to do with agentic AI or the concept of reinforcement learning. And in some cases, it does. So there is some deep reinforcement learning processes that do exist within large language machines and that have been incorporated. But for that in particular, separate from large language machines, there is several types of AI agents that you can actually be deployed in a variety of industries for a variety of reasons. This type of reinforcement learning, which is equivalent to other products like recommendation engines and personalization algorithms, play a role within basically having a trial and error method of an agent interacting in the environment, absorbing each state as it's making decisions, learning from those mistakes, improving on them, maximizing any type of rewards that it has within that state in the environment, back and forth. Its origin is actually behavioral psychology, not engineering. Reinforcement learning used to be called reinforcement and punishment theory. What a surprise they dropped the word punishment. I would have guessed that one's good for marketing. And so this type of theory and thinking has been around since the 1950s.
Wow.
It really got implemented into software programs in the 1960s by someone by the name of Marvin Minsky at MIT. And then afterwards, there was some trial and error methods. So what's really important here with AI agents or agentic AI, most of them don't have a model and they're model free. So there's no assumptions, no presumptions, there's no bias up front. It's basically an agent interacting with the environment, trial and error, learning from his mistakes for a long term reward. And it's really something that's kind of should have been done a decades ago. We've simply, I think a lot of people have a hard time understanding that when you want to employ an agent into a model, into an environment, excuse me, that it doesn't have a model. And that's quite difficult to grasp for a lot of people.
So, if you had to explain it to me in an elevator, right? How can I take an AI agent and implement it into my business? What would a practical example be? Because I love the history and how it's been around, but I'm curious if I want to deploy AI agents tomorrow into my business, what's one practical example that would create more efficiency?
Well, it is an experimental product. So you're going to be processing a lot of errors. So if you had a driverless car, uh, you'd have to maybe take, or maybe make it easier here. Let's say a flying drone that takes pictures. Uh, so this is a bit easier than an autonomous vehicle because an autonomous car because driving a car down the street has a lot of complexity with the environment, with cats jumping out over the street, stuff like that sort. But with a drone in the air, there's not much traffic. So what it's doing essentially is that if that drone was to, let's say, spot forest fires, or was it supposed to spot natural disasters, or let's say traffic, for example, nothing really in terms of emergencies. For that to actually happen, you would have to essentially go over a particular scope of area for your environment, let's say one single freeway, and do a trial and error method, whether or not it can identify traffic, how fast it's going, what are those objectives, see if it can actually forecast the next 15 or 30 minutes, and do this over and over again until it actually learns from its environment to maximize its states, whether or not traffic kind of moves fast forward. There's a whole bunch of other examples. There's robo advisors, for example, that exists within financial services firms that ask a series of questions. And when those questions are not processed correctly and the customer or client rejects it, there's a complaint and then it learns from that mistake. Don't do it again. So it is a trial and error method. It's, in a sense, I think this is really important to understand, is that it is an incomplete product that's in production. You have to be patient with it. But over time, it really generates those long-term rewards.
Awesome. That makes a ton of sense. And walk me through um, the coding side, right? In 2025, do you believe that you're going to have an AI specialist in your business, to continue to innovate? Do or do you have to learn coding, right? Is there no coding involved in AI? What do you see for 2025 when it comes to the technicality side of this with how quickly AI is evolving?
Yeah. Yeah, this is a sensitive subject area within data science. And really, not everybody, there's a small segment of people that are, I would say, emotional about this. Uh, and I would put it this way: coding is essential for data science and AI engineering, but no code solutions have existed for 20 years. And they might have existed even more than that. Um, at one university where I teach, I had to take over a course of a professor who was leaving. So I had to redo the video recordings, the PowerPoint slides, the content that was produced originally in 2005. So, yeah, 20 years ago. They used a no code vendor software solution with the random forest algorithm. So, this is what I would put it this way to kind of answer the question. There's an industry bias, and the fact that machine learning algorithms, almost all of them are decades old. So let me explain the industry bias. So for about 15 to 20 years, big tech companies like Google and Microsoft would encourage manual coding skills by donating money to boot camps, departments of computer science, and more. And they had $1 million marketing campaigns, and they hired actors to push everyone and everything to do manual coding, whether you were a doctor, a truck driver, and whatnot. So that's dying right now, since 2023, especially with the introduction of ChatGPT. The problem is that anyone who's actually is a data scientist will tell you that data science is not computer science. Software engineering is not a machine learning engineer. A chief technology officer is definitely not a chief data scientist. Um, just like a journalist is not a novelist, even though both a journalist and a novelist read novels to improve their work. So let me put it to you this way: you have two professionals sharing the same resources, but their objectives are different. A journalist reads novels to be a better writer in a newspaper, and a novelist reads novels to write another book, even though it's exactly the same novel. So, a software engineer may use the same programming language as a machine learning engineer, but for completely different reasons. So, unfortunately, the influence of big tech firms has given the impression of being a code warrior, even though there's at least 2 dozen no-code data science platforms that exist today, and they range from cheap to expensive. Um, that means that makes essentially that non-technical people can do data science, machine learning, and artificial intelligence using no-code platform solutions, or they can use code generation and debugging with large language machines. This is especially helpful for AI product management to go to market faster. But don't get me wrong, coding is not going anywhere. It's just getting altered. That's all. And one more thing I kind of want let me dig into this because I've talked to a lot of people about this. Is that from my university experience with artificial intelligence and machine learning, I would say a real data science bachelor's degree would have less coding than a computer science degree. Computer science is not science; it is applied engineering. If you took 1,000 computer science majors and you asked them, what is science? What is a scientific method? You would get 1,000 answers. Data science, on the other hand, is interdisciplinary, but at its central core is statistics. Also, a bachelor's degree in math has more math than a data science bachelor's degree, very much so. But don't get me wrong, math is there in data science with linear algebra, probability, statistics, some calculus, but nowhere near as much as a math major. Another thing I want to mention here is also the fact that you need to communicate better as a data scientist. You need to write and express yourself much more than a math major does, much more than a computer science major does, especially with storytelling with data. And, you know, aside from this kind of industry bias that kind of left people, it's also important to know the history of machine learning in that the first set of models that were actually implemented in software were linear models, but they're written on pencil and paper in the 1800s. They were implemented in the 1960s. Deep learning was written on pieces of paper in the 1940s. It was implemented in software programs in the 1980s. Ensemble models like random forests were written on paper in the 1980s. It was written into software programs in the 1990s, and so on. So 95% of real world machine learning models in production today is like going to a used car lot, buying a used car, taking that used car home, and then you're modifying it with new features like new wheels and new seats, etc. You are not buying a brand new car that's never been driven before and you're bringing it home. That is not what's happening. Data science is essentially taking an old algorithm and trying to fit it to new data for your objective. So, for this fundamental reason, automated no-code solutions exist because several decades have passed, giving plenty of opportunity for automation. Because when you automate, you reduce operational risk, you increase work speed. You'd also automate your data cleaning, data preparation, your data engineering. So altogether, I would say one last thing is that a good organization would have its software engineers reporting to a data scientist, and not the other way around.
That makes a ton of sense, and there's a mind-boggling amount of information there. Um, One question that I have for you, John, is I understand and I'm tracking everything that you're breaking down here. What I'm curious about is with your experience and the projects that you've worked within, but also are developing, what is the primary issue that you see that businesses are struggling with to adopt when it comes to AI right now in 2025?
we still have a mindset problem from 2024 going into 2025. Um, I wouldn't call it a matter of years of experience or what you've studied or intelligence. It's really understanding the workflow properly. It's also understanding any types of biases that exist, and really allowing your modeling and modeling phase to be the last thing of your worries, and focusing mostly on data strategy. This mindset is a bit as a problem. There is a solution jumping mindset where let's start with the model and then find the data with it, which is basically going, here's a solution, let's find a problem. I'm like, no, no, no. Other way around. Let's find a problem first and then worry about the solution later. Everyone's doing that. Well, not everyone, but a lot of people are doing that. And that mindset shift requires a lot of coaching and training, which I provide at the Global Institute of Data Science. It's a very critical method. It doesn't. I guess so many people are influenced by the marketing and artificial intelligence. Even very intelligent people who would have two PhDs. You still have to coach them and train them and tell them, when you see that on TV or you see something on YouTube, don't pay attention. Just focus on the proper workflow and focus on your data strategy, and then worry about what type of model you want to pick later on.
Awesome. That makes a ton of sense. And when it comes to your process and your approach within how you are developing these projects, consulting on these projects, walk me through what that process looks like. If I have a business and I'm looking to create efficiency in it, implement more data, have more data integrity, implement the AI side of things, what does your process look like and why is it different?
My process is kind of like, if I wanted to create a professional basketball team, let's say in Las Vegas. Let's make this interesting. Um, a lot of people will go, well, I would know which player should play there. I'm like, no, no, no. That that that's a solution. Let's try to focus on where it's going to be located. Does it have foot traffic? Can we get investors? The basics first. By way of analogy, you want to focus on your data strategy. And do you have data governance? Is the data clean? How do you know it's clean? Do you have any metrics on that? What is your strategy? Do you have any vendor data that externally that comes in and mixed with your internal data to enhance the quality of your data? Do you have any ideas about potential pain points that you have that you want to address? Because their first step is really, what is a business? What does it do? How does it make revenue? What is the costs and risks involved? Make that list first. Start from there. Identify those pain points and then see if you can focus on a data strategy at leading to eventually to a model that you select, or even reinforcement learning with no model to actually implement a real world solution. Don't get influenced by marketing and AI, even though no matter how powerful it is and how interesting it is, really focus on the basics at your current organization.
Love that. And what has been maybe a case study for you in the projects that you've worked on that you look at and you're like, that's something I'm really proud of. What is that?
Oh,
What is an example of a recent project that you've implemented that you're most excited about? And what did you guys do?
yeah. One of my favorites where I really knocked it out of the park here is I went to a very large global organization who had multiple subsidiaries, and they had two teams. One was a sales team. Like the average experience in that sales team was around 12 years. Some of them have been there for even 30 years. And then they had an engineering team, a technology team next to them. And they wanted to forecast the sales. They wanted to take all the smaller companies and roll it up to the overall company to forecast the exact sales volume, which would be in the billions of dollars. So next quarter, what is that number in billion? Next year, what is that number in billions? So that's the what they wanted to do. They wanted to do this to kind of allocate resources for their budget and multiple other reasons for marketing campaigns and things of that sort. When I walked in there for a month, just trying to learn about all the different types of companies, they had 20 offices around the world. They wanted to actually forecast the sales numbers every day, and uh, because They thought that these types of models, which were complex partial differential equations, was the way to go. And I simply just went over to the business, to the salespeople, and said, "Hey, do you want to know the sales volume for tomorrow?" They're like, "No." I'm like, "Okay, why not?" They said, "Well, anything can happen any given day. We're a very large organization. It's a bit random. It's not predictable." Then I said, "Okay, how about next month or next quarter?" They said, "Quarterly would be best. I mean, we've got dozens of businesses here." Okay. So I went to the engineering team. I basically took their project, which they gave me access to, and I rolled up their daily data, which was very dense and complicated. And I extended it to weekly, and then I extended that daily data to monthly, and then eventually to quarterly. And I developed a deep learning time series algorithm that was able to forecast the sales volume effectively for all the major subsidiaries and all of the overall company together. And I did this in 3 days, simply by asking simple questions about what is the business, what do they want to do, and what was their objective. And that was a very much a proud moment in my career history.
Awesome. Well, I appreciate you breaking that down, John. And I'm excited for episode 2, and we will see you guys on the next episode.